See, in ionic compounds, we've learned earlier that metals combine with non-metals, and that means that the metal loses electrons, the non-metals gain the electrons. Now, just for your information, just to show you what are the metals and which are the non-metals, see, group 1, group 2, and some of the group 3, most of them, and all these are called transition metals. All these are metals, and when they form a bond with these are non-metals. Group 4, group 5, group 6, group 7. Don't worry about the others which I have left out. We'll see about that later. But remember, when the pink ones form a bond with the yellow ones, that's the metals with the non-metals, then you're going to have, when this reacts with this, it's going to form an ionic compound. But when any of these two react, then they are going to form covalent compounds. Is that clear? So a metal reacting with a metal is forming a metallic bond. A metal and a non-metal form ionic bonds, and two non-metals will form covalent bonds. So metal with metal is a metallic bond. Clear? A non-metal and a metal form an ionic bond, and two non-metals form covalent bonds. Please be very clear about this. All metals, for example, if you take iron or zinc, they are full of metallic bonds only. We'll learn about that. Now, so let's look today at covalent bonding. Now, in covalent bonding, the atoms don't lose or gain electrons, they share electrons, and they will try to complete their outermost shells. Now, see, I'll give you an example. Fluorine will always try to become like neon. Oxygen will always try to become like neon. Nitrogen will always try to become like neon. Carbon will always try to become like neon. Likewise, chlorine will try to become like argon. Sulfur will try to become like argon. Phosphorus. See, they all try to become like the noble gas which is closest to them in the periodic table. So this is how they'll all try to become. Yeah, that means to complete their outermost shells and gain a similar electronic configuration. Is it clear? Now let's see how they work. Now, let's take some of the examples. Now the simplest covalent, they're not compounds, but the simplest covalent molecule is hydrogen, H2. Now let's see what is the structure of hydrogen. Now remember, hydrogen has only one proton and one electron. And if I draw another hydrogen atom, now I should represent this with a dot. They're called dot and cross diagrams. Now, what does it need for hydrogen to become like helium? For hydrogen to complete its outermost shell, it needs one more electron. So what these two hydrogen atoms will do is, they will now, their shells will overlap and they will now share the electrons that they have. So now, you take the hydrogen on the left. How many electrons does it have to its access to for itself? 2. And the one on the right also has access to 2 electrons. So they're sharing a pair of electrons. And this is what we call as a covalent bond. Have they lost electrons? No. Have they gained electrons? No. They're sharing electrons to complete their outermost shell. And hydrogen is a non-metal. So two hydrogen atoms form a hydrogen molecule, which is a covalent molecule. And we also represent this as H, single bond H by a single line. Is it clear? Now, let's take chlorine, Cl2. Now, chlorine has the electronic configuration 287. Now, it needs one more electron to complete its outermost shell. So, you have a chlorine atom, first shell, 2 electrons. Second shell, how many electrons? 8 electrons. Third shell, 7 electrons. Now, we'll draw another chlorine atom close by. And this time we'll represent the electrons by dots. So we can see the difference, okay? How many in the second shell? Should be 8. And third shell should have 7 electrons. Now what should happen? I'll just draw I'll draw the whole structure. Now first shell, 2. Second shell, 8. And third shell, now there should be an overlap. And this will have 1, 2. 3, 4, 5, 6 and 1 shared. Now what about the other chlorine atom? Same thing, 2 and 8 in the second shell and 1 shared here and 7 more outside that, 6. So is it clear now? So now look at the chlorine on the left, the outermost shell. How many electrons are there? 8. And the one on the right also 8 electrons. 7 of its own, 1 shared from the other chlorine atom. And this is Cl2. We represent this as Cl dash Cl. That dash represents the covalent bond. Clear? Now the next one. So is hydrogen and chlorine clear? Now the next structure is oxygen. Now oxygen is a little more complex. Now O2. Oxygen again is two non-metals. Two non-metallic atoms joining to form an oxygen molecule. Now remember the electronic configuration is 2, 6. So if it has to complete its outermost shell, each oxygen is short of 2 electrons. And it can share it with another oxygen atom. So 2 pairs of electrons will have to be shared. Now let's see how we draw that. Okay, I'll just draw the molecule, not the atom separately now. Okay, now see oxygen, first shell 2 electrons, second shell 6 electrons, right? 1, 2, 3, 4, and the remaining 2 electrons are going to be shared. Now that means there has to be an overlap with the other molecule and those will be dots. So you have 4 electrons outside and then the first shell will have 2 electrons. No, that's, I've just put the symbol in. Now here you represent this like O double bond O. Why? Because 2 pairs of electrons are being shared. So each shared pair of electrons is represented by a single bond. So you have 2 pairs of electrons being shared between 2 oxygen atoms and that forms the oxygen molecule. Now look at the atom on the left. How many electrons in the outermost shell? 1, 2, 3, 4, 5, 6, 7, 8. And look at the ones on the right. Also 1, 2, 3, 4, 5, 6, 7, 8 electrons. Is that clear? Then look at nitrogen. Now nitrogen electronic configuration is 2, 5. So how many electrons are needed to complete the outermost shell? 3 electrons. It should have 8 electrons, right, to complete the shell. Now what they will do is, see, nitrogen, first shell will have 2 electrons. Second shell will now overlap like this with another nitrogen atom and it will have 1, 2, 3 pairs of electrons being shared. Now out of how many in the outermost shell? 5. Out of 5 in the outermost shell, 2 are lone pair of electrons. These are called the lone pair of electrons. And you have the remaining 3 forming the bonds. So now you have nitrogen, triple bond, nitrogen. So how many covalent bonds are there between 2 nitrogen atoms? 3 covalent, called a triple covalent bond. Is it clear? So now look at the nitrogen on the left. 1, 2, 4, 6, 8 electrons. The one on the right also has access to 8 electrons in its outermost shell and they are sharing these electrons. Now all these that we have discussed now, we'll look back. If you look at hydrogen, now this is an element and a molecule, H2, made up of 2 hydrogen atoms, right? 2 hydrogen atoms make up 1 molecule. Likewise, Cl2 is an element and Cl2 is actually a molecule which is made up of 2 chlorine atoms. Is it clear? Now look at oxygen. Is it an element or a compound? This is also an element and O2 represents an oxygen molecule which is made up of 2 atoms. This is also an element which is made up of 2 atoms. The molecule is made up of 2 atoms. So it's called diatomic. 2. Di means 2. So this is diatomic. Is that clear? Now next we'll look at compounds. Now the next one is HCl. Now this is a compound. Why is this a compound? It's a compound because the molecule consists of 2 different elements, 2 different types of atoms. See, look at the first one. Oxygen, 2 oxygen atoms. They were the same. Hydrogen, 2 hydrogen atoms. Same atoms. But HCl, is it made up of 2 similar atoms or 2 different atoms? 2 different types of atoms. and that's why it's called a compound. Now, what's the electronic configuration of hydrogen? 1. Electronic configuration of chlorine? 2, 8, 7. So how many electrons does chlorine need to complete its outermost shell? 1 more. How many does hydrogen need? 1 more. Clear? So this is how they'll form a bond. Now look at, see, first we'll draw chlorine. First shell how many? 2. Second shell 8. Third shell, it has 7, right? So 6, not forming the bond. And now there'll be a hydrogen and hydrogen chloride gas. So this is HCl. It becomes hydrochloric acid only if it dissolves in water. But by itself, it's hydrogen chloride gas, which is a covalent compound. Is it clear? So now, is hydrogen and chlorine sharing a pair of electrons? And this is a compound because it's made up of 2 different elements, and we represent the bond as H-Cl, single covalent bond. Is that clear? Now next one is a little more complex. H2O. Now what does this mean? Now this is a compound and it's made up of 2 elements, hydrogen and oxygen. How many atoms of hydrogen? 2 atoms. How many atoms of oxygen? 1 atom. Now electronic configuration of hydrogen is 1, oxygen is 2, 6. Now let's see how they bond, okay? Now oxygen. First shell how many electrons? 2. Second shell 6 electrons, right? Now here 1, 2, 3, 4, and now the hydrogen hooks on. And now what will you have? See, have they formed a bond? Yes, like Mickey Mouse. Now look at oxygen. How many electrons does it have? 6 of its own and 2 dots from hydrogen. And each hydrogen has how many? 1 dot and 1 cross. So each hydrogen now has access to 2 electrons. So its outermost shell is complete. Each oxygen has access to, and the oxygen has access to 8 electrons. So its outermost shell is also complete. 6 of its own, 2 from hydrogens. Can you understand how they complete the outermost shells and form stable compounds? And this is represented like this. See, O, H and H, single bonds. Is that clear? So this is the structure of water. Now the next one is carbon dioxide, CO2. Now both are non-metals and that's why it's covalent. Carbon is a non-metal, oxygen is a non-metal. Carbon is group 4, oxygen is group 6. Now carbon electronic configuration is 2, 4. So it needs 4 electrons to complete its outermost shell. Oxygen electronic configuration is 2, 6, which means it needs 2 electrons to complete its outermost shell. And in this compound there will be 1 carbon atom and 2 oxygen atoms. So let's draw the carbon atom first. 2 electrons in the outermost shell, in the first shell, and 4 electrons in the second shell. And now you have the oxygen. And now we'll put the oxygen electrons as dots. So now oxygen, first shell 2, second shell 6. So 2 outside the common area, the area of intersection, and 4 outside the area and 2 inside, right? So the oxygen atoms are being shown as, the oxygen electrons are being shown as dots. So this will be represented as carbon double bond O and carbon double bond O. Each carbon is forming 2 bonds with the oxygen. Can you see? Each oxygen is forming 2 bonds with the carbon. Is that clear? Then the next one is methane, CH4, methane. Now it has 1 carbon and 4 hydrogens. Carbon 2, 4, electronic configuration. Hydrogen electronic configuration is 1. So carbon, first shell 2 electrons, second shell has 4 electrons, and they will be shared with 4 hydrogen atoms. So you have 4 hydrogen atoms here, and now each of them will share 1 electron with carbon. So now each hydrogen, does it have 2 electrons? And carbon will have 2, 4, 6, 8 electrons in its outermost shell. And we represent this molecule like this. Carbon with 4 bonds on each side, and each is bonded with hydrogen. Yeah, carbon forms a bond with hydrogen. Okay, now the other one is ethane. C2, ethene actually, C2H4, which we call as ethene. Ethene. The previous one was methane, this is ethene. Now look here. This has 2 carbons and 4 hydrogens. And this bonding is very complex. Now there will be first two carbon atoms. So look at the bonding very carefully. Carbon. And now they will form first a bond between two carbons. Is it clear? And then each carbon will have two hydrogens bonded to it. So is this clear? And the structure is represented like this. C double bond C. You can see the two pairs being shared between the carbon atoms in the middle. And each of these carbons then forms a bond with hydrogen. So all the valencies are now satisfied. The outermost shells are complete for each one. Is that clear? And then finally, ammonia. Now ammonia structure is, the formula is NH3. So both are non-metals. Nitrogen is a non-metal, hydrogen is non-metal. Nitrogen configuration is 2, 5. Hydrogen configuration is 1. Now nitrogen first. Nitrogen first shell, 2 electrons, and now 5 electrons in the second shell, out of which 2 will be a lone pair. They'll be by themselves, and the remaining 3 hydrogen atoms will pair up with 3 electrons from nitrogen. So the remaining 3 electrons will pair up with the hydrogen atoms, and this is the structure of ammonia. So we represent it as N, lone pair of electrons, and then hydrogen, hydrogen, hydrogen. Is that clear? So these are the covalent compounds, the structures which you need to know. Is that clear now?